All right, so you guys know you're in a geometry class, right?
Yeah.
You cannot do geometry without algebra. That's why you take algebra first, then you take geometry. So today, we're going to review those basic algebra skills that you're going to see pretty much every single day in this class, okay? So in your notes packet, we are on the back of the pink sheet. We're skipping over the vocab. Those are all geometry terms. We're going to the back of that first sheet. We're going to start just by reviewing the order of operations. So everyone's heard of this. Like I said, review day. None of this should be new. We are going to start with good old PEMDAS. Anyone remember what these words stand for?
I do.
Yes.
Parentheses, exclamation mark.
Exponents. You can finish it. Multiply. Very good. So we have parentheses, exponents, multiply and divide, add and subtract. The tricky part is multiply and divide happen at the same time. You just work from left to right like the way you read a book. Same thing for adding and subtracting. It's not like you add and then you subtract. You do them together, just working left to right. So, next thing we're going to talk about from your algebra days, like terms. Like terms have the same variable with the same exponent. Okay, power and an exponent, kind of interchangeable words there. So in order to add terms, they have to be alike. X squareds add with x squareds. X's add with x's. Constants, those are ones without any letters. Add those together. Thank you very much. Do you guys remember what coefficients are? If the letters are the variables, what are the coefficients? The number, yeah. The number before the variable, that's the coefficient. So the coefficient doesn't matter. Like a 2x and a 3x, you can add those, even though the 2 and the 3 are different, as long as the x's are the same. All right, you also need to remember the distributive property. That's when you multiply the term on the outside with all the terms on the inside of a set of parentheses. So if you have like a 2 and then an x plus 7, the distributive property says you can multiply the x by the 2 and the 7 by the 2, and you get 2x plus 14. Students are usually pretty good with the distributive property. Mm-hmm. We can throw a like terms example up there as well. So as long as the variable and the exponents are the same, you can add the coefficients. All right, first two examples, they are blank in your notes. It just says 1 and 2, so I'll give you a second to write these down. Now, in the first one, can anyone give me some like terms? Yes, ma'am.
3x and -2x.
Perfect. 3x and the negative has to stick with the 2x. So the variables are the same. They both have a 1 as their exponent, even though you don't see the 1. What's 3x minus 2x? 1x. Do I need the 1?
No.
Nope, just x. Good. Any other like terms? Yes. Oh. 4 and 7. Good. And 4 and 7, both positive, gives us
11.
Plus 11. Good. All right, raise your hand if you have questions on number 1. Number 2. Yes.
-5x and -4x.
Very good. When you're adding two negatives.
You get a negative. Wait. Hold on. No, I think that's multiply.
You are right. When you multiply two negatives, you get a positive. When you add two negatives, you get a negative. Even more into the negative, right?
So it would be -9.
Negative 9x. Perfect. I kind of covered that sign. Let's get this guy. All right. Positive 2 minus 9.
-7.
Negative 7. Perfect. Questions on this one? All right. Parentheses. Uh-oh. As you're writing, let's try to think about what you're going to do with those. All right. Any ideas how I should start? Yes.
Don't you like? There's a 1.
Yeah. I'm going to sneak in a 1. This is like distributing a -1. So I need to start by doing -1 times x and -1 times -8. I'm going to stick that negative with that 8. All right. The -2x, nothing changes. The +4, nothing changes. What is -1 times x? -1x. Good. I'll write the 1 in case you want to see it. If you don't want to see it, get rid of it. In the working steps, I don't mind if you leave things like 1s for coefficients. But in the final answer, I don't want to see them. It's kind of like the behind the scenes work. What is -1 times -8?
8.
Plus 8. Good. Now we can combine the things that are alike. I see 2 spots with x's. Both negative, so Adam, keep the negative sign. -3x. Our constants, we have a +4 and a +8, gives me a +12. Perfect. All right, same beginning on number 4, so we can jump right in. We are distributing a -1. 9x does not change. -7 does not change. What's -1 times 2x? -2x. What is -1 times +3? Perfect. All right, sorry. Sometimes I get excited. I just start going. I forget you're writing too. (9x minus 2x). 7x. Ooh, okay. These might be tricky. Yeah, it's going to be -10. The tricky part is just remembering that they're both negative. So, like, if you owe someone $7 and you owe someone else $3, you're in the whole $10, right? Same idea here. Both negative. Adam, keep the negative side. Who has questions? All right, number 5. Whew. Lots of distributing. So the first thing I'm going to do on my work is just sort of separate my workspace. I don't want to get these mixed up. All right, how do I start number 5? Yes. 5 times x is 5x, good. Minus 5 times 2 is 10. All right, next I have 6 times 2, which is, and it's positive, so plus 12x. 6 times 5 is
30.
Plus 30. All right, what is the next step?
Combine like terms.
What are they?
The 5x
5x and
and 12x.
12x is
17x.
good. Very good. You got to keep that negative. I keep saying it with the 10. Adding 30. When the signs are different, you actually subtract the numbers, keep the sign of the larger number. So our answer is going to be positive because 30 is bigger than 10. And then you just subtract them and you get positive 20. All right. Anyone know what I get when I distribute in the first set of parentheses? Yes. 6x minus 10. Perfect. Here I distribute the negative 3. Anyone want to give this one a shot? Yes.
Negative 3x. And then positive 8.
Yes. Negative times a negative, that's where you change it, okay? So that becomes a plus 18. Some people like to write it out step by step like a minus negative 18 and then change it. I just go right for the good stuff, okay? All right. Like terms, I have x's.
3
Very good. I have constants.
plus 8.
Plus 8. Same thing that happened on the last one. We were leading with a negative number, but the other number had a greater absolute value. There was more of them, so we end up with a positive, and then you subtract the numbers, you get an 8. Questions? All right, that was kind of like first day of algebra stuff. Now we're going to get into sort of what you did for a lot longer in algebra, and that's solving equations. So to solve an equation means isolating the variable using opposite operations. I usually call them inverse operations. So if you've heard inverse operations, that's fine, or opposites is fine as well. So that means to undo adding, we subtract. Undo subtracting, we add. Undo multiplying, we divide. Undo dividing, we multiply. So just try to get the variable. Remember, the variable is the letter. We get the letter by itself using inverse operations or opposite operations. All right. I think the hardest part of solving is deciding where to start. So if you look back to that order of operations that you had on the last page, it's usually a good rule of thumb to do those in reverse. So when you're undoing things, it's kind of like reversing, right? So you can do the order of operations in reverse. So first we're going to undo adding and subtracting. How do I undo? And you can put the little line of equality if that helps you keep things straight. How do I undo adding 6? Yeah, you're going to subtract 6 from both sides. 6 minus 6, those undo each other. They're inverse operations. Now you have a 0. We don't write zeros if there's other stuff going on. It's just a waste of space, okay? But this is like a balance. Think of like the lady you see if you're ever at the courthouse. Hopefully you're not. But there's usually like a statue of a woman like... It's like the sign of the law. I don't really know why. Keeps things balanced. But if you put something on one side of the weight, you got to put it on the other. Same thing with an equation. If we're subtracting 6 on the left, we're subtracting 6 on the right. Usually one side you just cross it out and the other side you actually do the math. So I have negative 5x equals 10. Perfect. Then we divide by negative 5. Very good. Oh. Yeah, the x is still on the left. So we still have this guy equals, and then 10 divided by negative 5 is negative 2. If you guys just put negative 2 and box it in, I'd be fine with that. Okay? What's going on number 8? That's division. Remember, there's a lot of different ways to write division. One of them is using a fraction bar. How do we undo dividing by negative 2? Yeah, so I'm going to multiply both sides by negative 2. Was ringing a bell? Negative times a negative is a positive. 6. Any questions? Okay. Now we're going to look at variables on both sides. Yikes. So the good news is there's lots of different, maybe not lots, that might be an exaggeration. There's a few different ways to do this. I usually say you want to pick on the little guy. So the one that has less value, it's easier to move that one and end up with not a lot of sign errors. If you move the bigger number, you end up with a negative coefficient. I don't like that. So, do we want to move the 2x or the negative 3x?
2x.
I did 3.
I mean, you could do it either way. I would probably move the negative 3x because then our answer is going to be positive. You know what I mean? Because how do you undo a negative?
No, let's do the positive.
You want to move the positive?
Let's
I'm
make it
open to
positive.
suggestions.
Move the negative.
Move the negative.
Okay, if I move the negative, I'm going to add 3x. If you did it the other way, you don't need to erase. Just double check that your answer is the same as ours when you get done. And when I say pick on the little guy, if you're looking at a number line, negative 3 is less than 2, so that's technically the little guy. All right, 2x plus 3x is 5x. Still have the minus 2. Still have my equal sign. The 3x's are gone. 3. Yeah, now we just do that PEMDAS in reverse. Whoops-a-daisy. There we go. Final answer? 1. Very good. 5 divided by 5 is 1. All right, number 10. Who's the little guy?
2y.
2y. That's who I'm going to pick on. You move a positive term by subtracting. So 2y minus 2y, those are going to go away. You have to subtract it from the place where you see the y's. All right? Don't subtract it from the 5. You're going to get all screwed up. They have to be like terms. 7y minus 2y is 5y. This guy just comes on down. Plus 5. Equal sign stays in the same spot. Y's are gone on the right. Positive 10.
Minus 5.
Mm-hmm. That's weird. What are we going to get? The same thing. And they both ended with 5 divided by 5. It's our lucky day. Number 11. 11. What do you want to do? Distribute the 2. 2 times 2y is 4y. 2 times 3, 6. Keep the plus sign. If you want that line, go for it. If you don't, that's fine. Honestly, as the year goes on, I will forget. I almost forgot on this one. But if you like it, you can go for it as long as you like. And then on the right side, a 14. Now what?
Minus the 6.
Good. Subtract the 6, subtract the 6. Keep that 4y on the left. Equal sign in the middle.
8.
8.
Y equals 2.
Very good. Divide both sides by 4 to get rid of that 4 as your coefficient. You get 1y or just y equals 2. What is n times n?
6 times 6.
You're one step ahead of us. N times n is n squared equals 36. Good. Do you remember the inverse operation of squaring something? What undoes squaring?
No.
Kind of looks like that's what you're. The symbols are similar. Yes, you take the square root. Thank you. What is the square root of 36? 6. Yes. The square root is like saying what number times itself would give you that number. Is 6 times 6 the only number times itself that would give us 36?
Yes. Wait,
No.
no. Wait,
Four
it's
is
4.
yeah, I think so. I think it is.
I think it is. Wait.
I still don't remember.
5.5. Hold on. Wait a minute.
Would I be making this ridiculous face if we were done?
No.
Hold on. Wait a minute.
No, it's not.
Yes. Negative 6 times.
Negative 6! I knew someone would do it. Yes.
Oh, yeah.
When you take the square root of both sides, you have to introduce this fun little symbol, plus or minus. Okay? And the reason is what we just said. If you put a 6 in here for both ends, 6 times 6 gives you 36, right? But so does negative 6. Negative 6 times negative 6 is also positive 36. So the rule is anytime you introduce the square root symbol, you also have to introduce the plus or minus. Man, I love reviewing algebra. Who's with me? Woo! Okay, first homework assignment of the year, and you got 20 minutes. You guys are going to be golden, okay? When you come in Monday, I'm checking it for completion. We'll go over the right answers. We'll answer any questions you have, and then we're rolling with geometry.